This lesson will cover segments and circles. So we're going to start with a couple of theorems when we're trying to find segment length. So the first one is chord. So we have a chord, and we have another chord. So if we just have a chord going from one section of the circle to the other side of the circle, touching, and then we have the other one, and they cross, and not necessarily at the center point, we're going to go ahead and label them. So if two chords intersect inside of a circle, so that one is divided into segments of lengths A and B, and the other chord is divided into segments of lengths C and D, then this is our rule. We have A and B multiplied together, so these are the same segment, and that would equal C times D, which is also the same segment. So on the same segment, we have 12 times 8 would be equal to 10 times x, or 10x, and then you would solve for x. So you'd have 96 is equal to 10x, and then x would be 9.6. So that's an example of the chord theorem to find a segment length. The next one is called a secant. So we're going to have two secants, and you can see that we have an outside angle that is formed. So we have a secant and a secant. And this is if two secants intersect outside of the circle. And they're labeled like below, so we're going to label them. So we're going to have A, B, so we have A, the little outside piece, and B. And we have C and D, and notice that all my points are labeled with big letters. The relationship is A times A plus B equals C times C plus D. So think part whole. So this piece here is the outside of the circle, the outside part, and this is the whole, so the outside and the inside, so the whole segment. So we would have the A and the B. And the same thing for C, it's the outside part, and then D, C plus D would be the whole segment. So let's do an example. In our example here, we again have two secants. So we're going to take the outside part, we're looking at the pink one. So we're going to take the outside part, which is 18, times the whole, added together. So 18 plus x would equal, the outside part of the blue is 16, times the whole, which is 16 plus 24. Then we're going to have 324 when we distribute, plus 18x is equal to 640. And we move over the 324, and we're left with 18x equals 316. And then that means x is 158 over 9, which simplifies down to 17.5 roughly. So that would be your final answer. Our next kind is tangent. So we'll draw a tangent. Remember the point that they hit right there is called the tangency. I'll go ahead and label it M. And then we're going to have a secant. So we'll go here. So we're going to think about this one. If a tangent and a secant intersect outside a circle, and the segments are labeled like below, then we have another rule. So we take the A, so the piece that's outside, so the A squared is equal to b times b plus c. So this is, the A is our tangent line. The B is the outside of the circle of the secant. The BC is the whole length of the secant. So this piece right here is all got to do with our secant. All right, so let's look at an example. We have a tangent and we have a secant. So we're going to take the tangent and it's going to get squared. The outside is the 4. And then the whole is the 4 plus 12. And now we're going to solve. So we have 4 plus 12, 16. 16 times 4 is 64. And then we are going to think about this as a quadratic. And we can take the square root of both sides. And we're going to end up with x is a positive or negative 8. Well, obviously we can't have a negative length, so we know that's out. So we are just going to have x equals 8. All right, we're going to do a couple examples. We're going to find the value of the variables using the given information, and we're going to check to make sure the answers are reasonable. So our first one here, we have a tangent in green. And we have a secant in pink. So this formula we know is going to be a squared, that's the tangent, p squared, equals the outside part times that whole segment together. So our tangent piece, our outside part, is 20, so 20 squared. And then our outside of our secant is y times y plus 30. We're going to go ahead and distribute. So we get 400 y squared plus 30y. Then this is a quadratic. I see that there's a y squared there. So I'm going to go ahead and get everything to one side equal to 0. And then I'm going to factor. So I'm looking for two numbers that multiply to negative 400 and add to 30. That's a negative 10 and a positive 40. And that is all equal to 0. Now, when I set these pieces equal to 0, I end up with y equals 10 and y equals a negative 40. Well, we cannot have a negative length, so this is out. So we know that our answer for our segment length of y right there is y equals 10. Let's look at number 2. This is a chord. So remember, our chord is we take the same segment on both sides. So we have an x and a 15, and we have the 9 and 5, and those get multiplied together and set equal. So 9 times 5 would be equal to 15 times x. So we have 45 is equal to 15x. So x is 3. Number 3, we have two secants. Formula, we're going to go ahead and plug in what we have. So we have this secant here, which is outside piece is x. And then whole would be x plus x would equal our other one here. We have a 9 outside. And then multiplied by the 9 plus 23. And now let's go ahead and solve. Here we have x and 2x. And then we're going to go ahead and multiply. So we have 2x squared equals 288. And then for this one, we can divide by 2 and just do an equivalence. So we end up with x squared equals 144. Just divide by 2 on both sides. And this is a quadratic, so we take the square root of both sides, and we get x equals plus or minus 12. And again, we cannot have a negative length, so our answer would just be x equals 12. All right, I want you to try 4 and 5, and then check back and see how you did. Okay, let's take a look at number 4. We actually have two little pieces, and I started out with our tangent and secant, seeing that, but we have two tangents and a secant, so we have to look at one piece at a time. So our first piece, I looked at our tangent here that goes at the bottom, and our secant here, and we didn't know at the time x. So I used my formula, plugged it in, and actually found what x was. So x could be 36, negative 36, or 4. We can't have a negative, so we know it's 4. Once I then put in 4, I then know what the x is, and then I can use that in my other piece to find y. So I use the tangent, I square the y, and then I have the outside piece, and then times the two pieces added together, and I end up with y equals 12 because y cannot be a negative value. Now for the last one, we actually have to look very closely. We have some extra pieces, and I started out with a chord. So we had a chord here and a chord here, and that helped me to find y. So I used my chord. 8 times 5 equals 4y, and got y equals 10. Now that I know my 10, this whole piece inside here I know is 14. And so my tangent secant for the other one, for this long piece that sticks out, and our tangent here is used for the other piece to actually find x. So I end up with x squared equals 95. I take the square root of both sides. I end up with a positive or negative square root of 95. Cannot have negatives, so I know that x is the square root of 95. Talk about a couple of more properties of tangents. So we have a circle with two tangents. Notice that they are coming out from the center. The radii is coming out to the point of tangency, and they make a 90-degree angle. The same is true for the second one. You have two tangents that form a circumscribed angle out to the side, and they also come from the radii out to the point of tangency and form a 90-degree angle. So one of the rules is that an angle between a tangent and a radius to the point of tangency. So here's our tangency point, So from the radius, so the radius is from the center out to that point, forms always a right angle. So that's important to know. So it may not be marked, but that's a rule, that's a property that always occurs. Another thing you need to know is when we have a circle that's inscribed inside of a triangle, if the tangent comes off from the same point, you're going to have congruent sides. So, for example, if I have this point, I'll use a different color here. If I have this point here, and I'm coming off from here, and I'm coming off from here, these two pieces are going to be congruent. So that means if this is A, this is also going to be A. The same is true for the other point. If here I'm coming off and coming off, these are going to be congruent. So maybe this is B and this is B. And then for our last piece here, it's coming off, and this would be C and C, and they're congruent. So that's another property of tangents when we're talking about inscribed shapes. So let's talk a little bit about some chords. So we have a few chords here, and if we have a chord and they're kind of at an angle, we can see that these right angles here, we're going to have some congruency. So we would have this and this line will be congruent, and notice that they meet at a 90-degree angle. So those angles are congruent. We have ones that are straight across, and then we have diagonals. We know that these two angles would be vertical, and then these two lines would also be congruent. If we have something like a diameter coming off of the center and then a chord going across, it creates a 90-degree angle, and then this piece and this piece are congruent. So those bisect. Our other property is if we have two chords and they're going equal on each side, this would be congruent to this line, and then this arc will be congruent to this arc. So it's like it's equidistant from the center.